This Hall effect is an interesting effect, which is a consequence of the Lorentz force in some sense. That if you're having current that is flowing through a conductor, if I have a piece of conductor and the current is flowing through it, that means the electrons are moving from one point to another. Because of the presence of a B field, which in this case is indicated by the cross, the Lorentz force kicks in, and this charge will not go at the center, but instead it will deflect and start moving like that. Instead of going at the center, the charge moving at the center, it's going to deflect and go along. So that means it's not in the center of the highway lane, but it's going to the rightmost lane or leftmost lane, depending on the direction of the magnetic field. Depending on the direction of the magnetic field. That means what? That means a charge is not at the center line, but shifted towards. That means there is a potential difference between this lane and this lane in the highway. But I would strongly encourage you to go and watch the YouTube video, because it's a very useful sensor to detect how much is the magnetic field, because we know that the Lorentz force is going to be proportional to V cross B by the amount of current you send in, this first term, by the amount of force that it experiences, you can find what is B. This force that it experiences is going to translate to the potential between this point and this point. So a Hall effect sensor will be able to find that potential difference and translate that potential difference to the force and eventually to the magnetic field that you are going to measure. So that potential difference is called as the Hall EMF. EMF means electromotive force, which is the same as potential. It is also used in motors to detect how much is the magnetic field around it, how is it changing, so on and so forth. You can detect a current without establishing a contact with the wire. It can be a contactless sensor, because once you have a wire with the current flowing, you know that there is a magnetic field around. If I were to sense just that magnetic field, I can find what that current is. So I don't have to go and connect a meter by probing or by cutting and probing and placing a meter there. I don't have to do that. I just have to wrap around and find what is the current around.